So to record from a neuron, let's say intracellular recording, what you have to do is measure that transmembrane potential. And there are a lot of tricks involved in doing that. The first thing you have to do is get a sharp glass pipette that impales the cell. The cell's membrane seals around the glass, and so it forms a junction where the only way you're communicating to the inside of the cell is through the glass pipette. The cell membrane is an insulator, and the glass pipette is an insulator. But the glass pipette is filled with a conductive solution, typically a 3 molar potassium chloride solution. That's the most common. And then there's a wire in the back of the electrode as well. I have an additional wire which is in the bath or the solution around the cell. So those two wires, the one in the back of the electrode and the one next to the cell, go back to an amplifier. That amplifier then will look at the potential difference across the cell membrane. And the amplifier signal is further conditioned, and there's lots more little tricks to it, but eventually go back and we have a display on an oscilloscope and it gets logged by a computer. One of the most important parameters that's required of the amplifier that records the transmembrane potential is it has to have an extremely high input impedance. What that means is that the cell doesn't really see the measuring amplifier. If the input impedance, or think of it as input resistance of the amplifier, were too low, it would short circuit the cell. The cell has a potential difference across it, but it has very little ability to source current. And so you have to be able to measure that voltage without drawing any current out of the cell. And the way you do that is to have an extremely high input impedance in your amplifier. So it's a very specialized kind of amplifier. Glass pipette recording is usually intracellular. It doesn't have to be. You can use a broad or blunt tipped pipette and record extracellularly as well. But typically that's glass pipettes used for intracellular recording. And metal electrodes, for instance, tungsten electrodes, are used for extracellular electrodes. And there's also a crossover technique where you can melt indium metal. It melts at a very low temperature, and you put it into a broken off-tipped glass pipette, and you squeeze out a little ball of indium metal, and you plate it, and that was developed by this fellow Jerry Lettvin back, I think, in the early 60s, and they're called sometimes Lettvin electrodes. It's a combination of a glass and metal electrode, and those work great.